RGB get read in here as floats, and you take the pixel that you're given and set the color of whatever you're wanting to draw to whatever value that pixel gives back. And of course we divide by 255 because all values will be between 0 and 1 because that's how GL color 3F works. So that corresponds to whatever color, whatever image you have. And now to draw continuously when you drag, this one's not that hard. Basically, you have to go into callback mouse. And what happens here is this tests whether or not the mouse button is held down or not. You can actually draw with all three of these, I believe. So what happens is it checks the state of the mouse state of the left mouse button, right mouse button, and the middle mouse button, and sees if it's either held down or released. And so what happens is inside of callback, no, not callback motion. I think it is in callback. I'm sorry. Here's callback mouse. Here's the draws. Oh, it is in callback motion. So yeah, in callback motion, it basically calls and sees if your mouse button is held down, and if so, draw the image. Otherwise, just go over it. There's no callback passive here, is there? Nope, there doesn't seem to be a passive function here anyway. So we just go through the motion func, and as long as the mouse buttons are held down, you will try to draw an image at that pixel, at your mouse position. So let's go over actually how to orient the stroke in the direction of the mouse. So to orient the stroke in the direction of the mouse, you actually have to find the last coordinate of your mouse, so the last x and last y. Last x and last y are actually px and py here. They are integers and they are declared as global variables. So what happens is you substitute, or you don't substitute, you want to sort of make a triangle. As you can see here, we have the pixel tpix equals pixel, canvas xy, which is your mouse coordinate, and we have the opposite and adjacent parts of the, I guess, triangle, you could say, between the point that you want to draw and the point that you were previously drawing. And here we have a float called angle, which takes a tan 2, which takes the tan squared, I believe, of the opposite and adjacent to get the angle of the hypotenuse, which will control GL rotate F's angle at which you draw your next object, which in this case is a triangle. So what happens is you have to load the identity in, translate it some distance away so that it, translate it some distance away such that you can rotate it effectively. So in this case, I actually GL translate F to that and then rotate by the angle times 180 over pi, which is accurate. So you get accurate rotation, and then you translate back. And that's how you're supposed to do it. And then something that appears like the source image appears when used. I can't explain that. That's the whole point of this program. Now, providing a keystroke or menu to clear the canvas, we have a function here called callback keyboard. And I believe, if I remember correctly, the keyboard command to clear the canvas was C. So callback keyboard is basically a huge switch statement which takes in the key. As you can see here, is an unsigned character. The key actually corresponds to which button on the keyboard, and the button to clear the canvas was C, so we're going to actually go down to case C right here. And as you can see, all this does is it takes the entire canvas and basically draws a vertex 2i at everywhere, or at that spot. It's a nested for loop, and basically clears the canvas by making everything black, which could cause some problems in memory if you were to overuse this function, but I don't think it matters much for this assignment. Now here's a provide a key menu to change brush size. That keys, I remember correctly, are Z and X. We have global variables called brush size, and if memory serves me correctly, you update the brush size inside of every single draw. So what happens is you want to draw anything really, and here we have X minus brush size, Y minus brush size. So what this does is it takes your mouse coordinate and tells the computer what, or not the computer, but whatever. It takes your mouse coordinate and draws some object based on your predefined brush size, which you can change. So Z and X to change your brush size, and the key to menu to change brush shape, that is case M, in which you press M to cycle through the available brushes. And actually I overshot it. Here we go. We have another global variable called brush state, which controls which state the brushes are in. And inside of the draw here, we have if brush state equals 1, 2, 3, 4, 5, 6, etc. Actually 5 is the eraser, so we don't have that here, but as you can see, that is how the brush shapes are controlled. And of course the last criteria is provide an eraser. We're going to skip over don't crash because mine only crashes when given a bogus file name, or rather no file name. But you provide an eraser. So the eraser is E, case E in this. Let's see if I can find it. Here we go. And we have another brush state here, which is outside of the other brush states. Is actually the erase one. So we have two boolean here, or actually an integer, can erase, and brush state. In here. And here in the callback motions function, which we draw everything in, what happens is we have something to set red, green, and blue to 0 to give you a black polygon, drawing whatever. And so we set GL color 3F to be 0, 0, 0, so it's black, effectively an eraser, to the default color black of the canvas. And here we have GL vertex to Y, so you can modify the eraser brush size as well. And so that is basically everything inside of lab1.cpp, everything that I turned in. Hopefully this made sense to some of you. People that will be in future classes might get some help from this. I showed you my source code. That was everything that I could come up with, and I actually wish you good luck if you happen to be trying to implement this in the future, or if they do this in another 160 class. I hope that this has been a big help. Thank you very much.